Hello, I am Michael Tam, a GP academic from the University of New South Wales. I have the honour of presenting the findings of a medical education study that we conducted earlier in the year. The other team members include Dr. Joel Ree, Senior Lecturer and Convener of the Primary Care course, Mr. Chris Goh, a final year medical student who was supported by a GP scholarship from GP Synergy, and Dr. Chintika Balasuria, an experienced medical educationalist. Medical students at the University of New South Wales complete the primary care course in either their 5th or 6th year of study. This course is 8 weeks in length, and students spend most of their time in community general practice placements, at least 50 half-day sessions. Students have told us that they would like more structured content learning from the course, but they are on campus only the first 2 days of the term, one afternoon in week 4, and on the last day. Perhaps online e-learning modules could be a solution. We used the Smart Sparrow platform. They are a UNSW spin-off company, and there was a project officer who could assist us. This platform allows for case-based learning activities, multimedia, and can give deep learner usage analytics. Our aim was to compare a pilot e-learning activity with an equivalent traditional learning activity, in this case an interactive lecture. We wanted to assess differences in student learning outcomes, learner satisfaction, and student attitudes to different types of learning activities. From the medical school perspective, we wanted to evaluate the differences in development cost. This was to inform us on how we were to proceed with revising and further developing the primary care course in 2014. Firstly, we chose hypertension as the topic for this study. In the initial part of the learning activity development, we created a common set of learning outcomes and a case scenario. Throughout the learning activity process, we logged the time spent. Next, 2 members of the team took the learning outcomes and case scenario to independently create the learning activities. Each member developed the activity that they relatively had less experience with. Joel developed the e-learning activity, and I developed a lecture. We kept each other blind to what we developed. We logged the time. On the final day of Term 2 this year, we recruited medical students who had just finished their primary care term into the study. Those who consented completed a pre-activity questionnaire along with a hypertension knowledge test. Allocation to the study arm was revealed after the completion of these forms. The randomisation schedule was created by Chris, our medical student investigator. He used an online generator, block size of 4, stratified by year group. The allocation was initially hidden in a sealed envelope that each participant received at recruitment. Participants in the e-learning arm completed the activity in a computer lab, and the other participants received a lecture in a classroom. The students completed a post-activity questionnaire and the hypertension knowledge test again after the learning activity. We compensated our participants for their time by providing lunch. All the data collected was then subsequently analysed. This study received ethics approval from the University of New South Wales Human Research Ethics Advisory Panel. The hypertension learning outcomes and case scenarios were developed in consultation with another GP academic at the school. There were 4 final learning outcomes: perform BP measurements properly, conduct comprehensive assessments in hypertensive patients, identify patients who should be commenced on drugs, and to describe appropriate pharmacotherapy. Our case scenario involved a middle-aged woman, Claire, who presents with raised blood pressure over 3 consultations at age 40, 55, and 56. The knowledge test was directly based on the 4 learning outcomes: 2 single best answer MCQs and 2 short answer questions per learning outcome, and we pilot tested it. The tests were marked in a single sitting to ensure consistency in the marking. The pre-activity questionnaire included basic demographics and asked students for their baseline learning activity preference. The post-activity questionnaire asked the student perceptions about the learning activity, the use of media, and quality. We also inquired about their beliefs and attitudes towards e-learning. We used both quantitative and qualitative methods in the analysis. We analysed the pre- and post-activity knowledge test scores Cohen's d was calculated to determine the magnitude of differences. Significance testing was with t-tests. Learner satisfaction, descriptive statistics, and some significance testing, along with looking at the qualitative feedback. Student attitudes, mostly through looking at the free text comments and analysing for themes. Development costs, tabulating the total time spent on the development of each learning activity. The results. This is a chart of participant flow. A little over half the primary care students in teaching period 2 participated in the study. There were no significant differences in baseline characteristics between the two groups. Learning outcomes. Now for context, the maximum achievable score was 24. The baseline knowledge between the groups was similar. The lecture group had a small non-significant higher score. Both groups had substantial improvements in their knowledge test scores after receiving their respective learning activities by over 1 standard deviation. The lecture group trended towards a higher knowledge score than the e-learning group, a small moderate difference, but this was not statistically significant. Learner satisfaction. The leftmost is strongly disagree and the rightmost is strongly agree. The lecture received higher scores in student feedback in most questions, though scores were high generally. Students in the lecture group reported being more satisfied compared to the e-learning group. This chart could explain some of these findings. When students were asked to compare the quality of the learning activity to others of the same type that they have previously attended, that is, the lecture compared to other lectures and the e-learning activity compared to other e-learning activities, the lecture appeared to have been comparatively rated better than the e-learning activity. About half the students preferred face-to-face learning activities at baseline. About a quarter preferred e-learning and the remainder claimed no preference. The major theme that emerges from the comments of students who preferred e-learning had to do with being able to control the pace of learning as well as the convenience factor. The major theme that emerges from the comments of the students who preferred face-to-face activities had to do with the value they placed on the learner-teacher relationship. Despite the preferences though, students did seem to relay that there was a role for e-learning, but perhaps not as an alternative to traditional learning activities. Rather, students saw the role of e-learning as an adjunct or supplement to other activities, or could be used for self-study and examination preparation. The development costs results are interesting. Firstly, the common part of the learning activity development, the development of the learning outcomes and case scenario, 7 hours in total. The next part, the lecture, 11 hours. The e-learning activity, 19 hours. However, this doesn't include the time spent by the Smart Sparrow project officer, which was 50 hours. The tally, 76 hours total for the e-learning activity and 18 hours total for the lecture. I want to stress that our study does not demonstrate that e-learning activities are worse than traditional activities generally. However, there are a number of important implications we feel that come out of our results. Firstly, developing e-learning activities can be a costly exercise, or put in another way, it needs to be adequately resourced. In this study, over 4 times the number of hours were put into the e-learning activity compared to the lecture, and it did not show or trend towards attainment of better student learning outcomes or student satisfaction. The next is pedagogy is more important than technology. Emerging strongly from the comments of this small group of medical students is that they value the relationship they have with teachers. From the educational literature, we know of the importance of social learning, elements that are non-trivial to replicate on an e-learning platform. We shouldn't implement technological approaches simply for the sake of doing so. In our context, e-learning offers a learning opportunity that otherwise wouldn't exist and so is valuable. Student attitudes to learning need to be considered. Assumptions that learners prefer the convenience of learning at home may be unsound. Our students seem to tell us that although they saw a role for e-learning, it was not as an alternative to more traditional learning methods. Lastly, building quality e-learning activities requires new skills and tools that we medical educators may have little familiarity with. Good user interface design is hard. Even harder is implementing that design. Most of us probably have a good idea of what makes a good clock. Some of us might be able to draw one, but few of us can actually build one. Thank you.